Okay, so for the bell work, we're going to first solve for x. We'll subtract 8 from both sides, and we'll have 3x is equal to negative 18. We'll divide by 3, and we'll say x is equal to negative 6. And the third root, okay, so when the root or the exponent is odd, that means I can keep my negative sign, okay? So negative 1 times negative 1 times negative 1. Well, I don't care about equal, not really. Well, it is equal to negative 1. I mean, it is. If I multiply them together, I do get negative 1. But I'm just going to take one of these. I'm just going to take one of them, because I'm looking for triplets, right? So then I take one of the triplets, and y is equal to negative 1. So everything's negative 1, but anyway. So we need to know that before we start to evaluate. We're going to say the absolute value of negative 6 then, for that, times, this is a negative 4, so I had to say 1 over negative 1 to the positive 4, you understand? Minus, let's see here, again, I'm going to say 1 over negative 1 is y to the positive 3, okay? And then and so forth and so on like that. And I'd say you'd have to get common denominators, but when your denominator is 1, it's not too bad. Okay, you can go ahead and finish that. If the product of 3 and a number, so 3 times n, is increased by 13, 3 times n plus 13 is equal to 12 less, so I'm going to subtract 12 from something, but I have to know the something first, twice the opposite. So opposite means a negative sign, so a negative 2 times, did I say x or n? I can't remember. Negative 2 times n. So I guess I'd subtract 12 from the right side. I mean, I could add 12 so it'd be equal, because I don't want it to be less than. I could add 12 on the left side, then it wouldn't be 12 less, would it? Either way, expand using the distributive property, and I guess I will let you do the first one here, and I'll do the second one. Maybe I'll do a different colored arrow for that. Here's, oh, didn't change. Try this one. Okay, and I'll have you do that one. Plus, let's see here. What do we have? We have x to the negative 4th times x to the negative 4th. I'm going to add exponents. Well, first I guess I better write the 2. I'm going to add exponents. Negative 4 plus negative 4 is negative 8. And I have y to the 1, and I have y to the minus 1, so I'm going to subtract a negative 1. So I have y to the 2 now. And let's see, I have negative 2 on top, and I'm going to subtract a positive 2. So that's going to be p to the negative 4th. And I want all my exponents to be positive. Okay. So I guess the 2 and the y squared get to stay on top, but then x to the 8th goes on the bottom, because I need to change that to a positive. And I need to change this to a positive, so it's going to be p to the 4th on the bottom. Plus whatever you got the first time. So solve for x. All right, so we're going to distribute. Now take the negative 3. Don't fool around. Just keep that negative with it, okay? So you have negative 3 times negative 2, that's positive 6. Negative 3 times negative x. Yes, that x owns the negative sign. So we get plus 3x. And then we say 3, and it's just this 3 right here. It's not the negative, because if it were the negative, I'd put that inside. But I don't. I haven't. There are no parentheses. So it's a negative 9. And then the absolute value, well, that's going to give me a plus 2. But then here is the negative sign to make it negative again. And you can carry on like that. Collect all the x's on one side, collect all the numbers on the other, and divide by however many x's you have. And, well, I guess that may not be necessary, but anyhow, go ahead and solve for x. Get x alone.